Hello. This example draws a simple triangle without transformation using OpenGL 3.3 and Qt 6. I want to explain one example that draws a transformed triangle. By default, OpenGL uses a coordinate system from -1 to 1 for x from -1 to 1 for x and from -1 to 1 for y. A beginning of the coordinate system is here by default, but using a orthographic projection matrix we can set a beginning of coordinate system in every point on the screen. For example, we can place it here in the left bottom corner, and we can set it here in top left corner or here somewhere. For example, if we place it here, we can point y-axis here to bottom. So let's see this example. It draws a transformed triangle. I set angle for this triangle. I set angle here 20 degrees. I rotate it around the axis. I set translation. I set a position to 1030 and I set size width 25, height 25. This is CMake list file. This is version, project name, standard 17. I don't know what this option means, but I think it's necessary. It doesn't work without this option. Find package, it is packages that we want to use. OpenGL widgets. Here is add executable. It means that this is the name of exe file. App exe file will be created. Target sources, set path for source code. Target link libraries for linking libraries. It is the same names for packages, but in this case. So next, let's see. We have one class, main window, and the main CPP file. So we include main window class that is located in these two files. We set desktop OpenGL it will be ignored for Android or for WebAssembly. We create application here. We created format. This variable to set core profile of application, major version, minor version 3.3, OpenGL 3.3, set samples. It is for anti-aliasing. Here is window. We set format that we created before. We set geometry and we show window. Let's see on window.h file. We include what we need here. We need window functions. OpenGL window we inherited from this. Here is OpenGL program. We use this variable to keep program. Here is OpenGL vertex array object we need it here, and OpenGL buffer VBO to keep vertices, positions of our triangle. We should create view matrix. It is camera projection matrix for orthographic projection view matrix to keep them together. We multiply it and keep it here. Model matrix for translation, rotation and scaling. MVP matrix, it is general matrix for multiplication of ProView matrix and model matrix. We keep it here and we send it to vertex shader using this variable. It is variable to send matrix. Initialize.gl will be called only once at the beginning of program. Resize.gl will be called every time when we resize our window, and paint.gl will be called when we need to redraw it. We can use this paint.gl function to animate our objects. But I disable calling paint.gl every frame by commenting this line. Paint.gl will be called only when it's necessary to update. For example, it will be called only once without this line. So let's see what we have here. This constructor, destructor to destroy VBO and VAO and delete program. Initialize.gl, we initialize OpenGL functions. We create two shaders, vertex shader and fragment shader. Here is setting of background color. We create OpenGL shader program here. We send vertex shader source and fragment shader source. Here is vertices. It is first vertex, second vertex position and third vertex position for a triangle. Here is creating and binding VO. VO used to keep settings for VBO. It keeps this, and we need VO to bind these settings. Here we bind VO and we draw this VBO with these settings. It is settings for a position attribute. The vertex shader. Vertex shader will be called 3 times after calling this draw arrays function. And it will get this vertex position to this variable at first time. At next time it will put this value to position, and in the third time it will put this to this position, and MVP matrix, model view projection matrix, will be multiplied on this position. After sterilization, we will have array of fragments or pixels, and we set for every fragment shader will be called for every fragment. Fragment can has a few pixels, and we'll set a color for every pixel. So here we set a project matrix here. From this left side of the window, this is minus 15, it is here for x. 15 is here for x axis. Minus 15 for bottom, it is y axis. 15 is for top. We can set, for example, minus 100 to make our world bigger, or minus 10 to make it small. So we set project matrix here. It is for z-axis from minus 1 to 1. It is near and far. How to say it? Okay. Here is a general matrix for projection matrix that we set here, and view matrix. So I can okay. Here is a mistake in this example. I need to set mproj matrix set to identity here. Yes, because as you can see, you saw that the triangle was disappear when I resize a window, but now it's good. Everything it works. So it's very necessary to set to identity, because without this this operation ortho will be applied over and over again. So here is a painting. We clear screen, we bind to this program, we bind VO, we bind these settings, enable attribute 0. Attribute 0 is location 0, it is position in the vertex shader. So it is y, this is 0. This is 0, set attribute buffer to settings. OpenGL float. It is because it is float variables, float arrays. Here is 0 to offset, and 3 it is because three values for one vertex. So it is because vector 3 here, it is y is here, 3 here. Okay, let's see what is next. Model matrix set to identity. It is very necessary, like here. This is translate to set position. Yes, we apply for this matrix this method, and we set position. We created a translation matrix when we apply it to model matrix. Here is rotate. This is for rotation. We rotate for 20 degrees around z-axis. It is a vector. It is z unit. Here is a scale. We set width, height, and deep. Deep will be 1 because it is 2D. This doesn't matter what will be z or deep. This is a general matrix. We created ProView matrix and we multiply it on model view matrix. So we have now all matrices: rotation, rotate, scale matrix, and ProView matrix, projection view matrix, and view matrix here. Okay, I didn't say about view matrix. View matrix is a position of a viewer. It is eye position, it is target position, it is direction, it is point where it is look for. It is a unit vector for a viewer. It means that top of viewer is directed to for y-axis. Okay. So next we just send. We use this location. It is we get location here to keep it in this variable, and we use this variable to send this matrix, MVP matrix, to shader program to vertex shader. Here we send it here, and we draw it. We call vertex shader 3 times, and it will get this value, and this value. At first time it will get this, it will put here, and MVP matrix will be multiplied on this position. At the second time it will put this value to this variable and set position, and for third it will be the same. So we release it. It's all. It works. Now we have a field from -15 to 15, from -15 to 15, and we set position 10, 30, 10 here, 30 here, rotation around z-axis for 20 degrees. Here is scale, the size of triangle. Thanks for watching. Bye.